Hey everybody, this is Larry. This is day 22nd of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Stone Game 4, which is a game theory problem probably, because that's all the other Stone games, right? Anyway, hope everyone's doing alright. I'm still playing around with this new keyboard just to give a little bit of an update, because I sometimes do these things like a relog or whatever. I'm looking down because I have this new keyboard and it's kind of nice and shiny. I don't know if I can see it. Okay. And it has like nice colors. I don't know. I'm still kind of getting used to it. So when you see me type, and I have a lot of weird typos, actually, it's pretty okay on like the actual word keys, but I have trouble with the brackets and, like this without looking. Which of course when you're doing programming is a good part of it, so I'll see how I like it. So if you see me do a lot of typos, this is why, because I'm still adjusting to it. Okay. And also the stock market's been kind of sad. I don't know, let me know in the comments if stock market's treating you good. Anyway, today's problem is Stone Game 4. Oh, let's see what it is. Alice and Bob takes turns playing a game, and it's always Alice and Bob. Larry never gets to play, but Alice does go first. Okay, initially the end stone in the pile. Each player turn to take a move consists of any non-zero square number of stones in the pile. Also, if the player cannot make a move, he or she loses the game. Given n, return true if. Okay, what is n? N 10 to the 5th is a little yikes. Huh. I mean, the complexity part is kind of tricky, to be honest. There may be some. See if they let me. I think to be honest, these kind of problems, there are really only two solutions, or two type of solutions. One is what's it called? Game theory, dynamic programming. I'm not gonna get into it that deeply. Maybe not yet, anyway. And that's just kind of what it sounds like. You have some min max type thing, or some kind of what's it called? Equilibrium type matching type thing. It's either that or NIMS game type thing. But those things are, well, NIMS game is probably not going to show up on your interview, Nimbers and stuff like that. But that does come up from time to time in competitive programming, but not so much in general. The dynamic programming recursive game theory one, maybe that comes up once in a while, but I don't know. And this is a hard problem, just kind of get a little bit of a cheating context, which is why I didn't like it when they first introduced it. But and then the other thing is just see if you could find a pattern, right? And if figure out how you could play the game optimally. And and with that works very often, that is some sort of greedy or something like that, or some kind of intuition. Which also relates a little bit back to the numbers thing, but maybe more in an implicit way. So I don't know which one this is. I might even have done it before, but it's just like a weird problem, and there's no reason for me to memorize it. So let's see. Let's play around with. So what I like to do is play around small numbers and see if I could see a pattern. And sometimes I like to kind of write it out. What one is Alice wins, two is Bob wins because Alice can only remove one. ... Right? And then another way to kind of do this, of course, and you can definitely. Part of this exercise is kind of figure out the visualization and the mental and kind of thinking about how to mentally get to it. But another way that you can do though is by writing a brute force type algorithm to see yeah, writing a brute force to kind of print it out for you, right? So you don't have to do it manually. And in this case, I do know how to do the dynamic programming one, but I do feel a little sketch about 10 to the 5th. It may be a little bit too slow. Because 10 to the 5th times the square root of 10 to the 5th is what, like 10 to the 7th to the 5th? 7.5, I mean. So that may be a little bit too slow, at least in Python. I don't know. But yeah, I'll get it for some small n, and then kind of play around with the idea, right? So yeah, so now I'll just write it recursively because why not? And here, usually I do a no, actually let's write it the other way, right? So let's say this is Okay, so winnable is equal to true. Keyboard is still a little bit awkward. Okay, so that means that if you get to a no wait okay, so actually no, I was gonna say something about getting to 1 being the save point, but actually no, I'm wrong. I think false is the save point, meaning that if you could get to 0, then that means that, or if you're at 0, that means you cannot win, right? So your goal here then is to get to a state, or be, if you start at a place where you can take 1 move and then your opponent is false, then you win, right? So something like this. I'm just gonna write a big number so that I can print it out. Maybe that's too big though. Yeah, and we start at 1 because we already have thing here. Right, and then here we can do the moves of these loops are always a little bit awkward to write in Python, to be honest, but basically now if we can take this, if we take this move and the opponent cannot win, then winnable is I keep on this is really annoying me, bugs me. What the page up and all that stuff. This keyboard, I actually do enjoy the keyboard a lot, but I'm still getting used to a lot of the weird placement of the brackets, like I said. Yeah, so that means that this is a winnable state, meaning that if you start here, you win, right? Yeah, and of course you can actually use, now that you can, then because we live in new Python now, right? And then that's pretty much it. Otherwise, yeah. And then we just have to return winnable sub n, meaning that if I start there, do I win, right? So let's kind of see if that works quickly, just to make sure. I forgot to increment j. This is why I like other language where you could write this as a for loop, and I'm so used to thinking it that way that I actually do this a lot, but at least it's an easy debug. I know I forgot it because it's an infinite loop. It doesn't make sense otherwise. So yeah, so this is going to be okay. But then the question is, okay, so I want to print out small n's to see if I can see a pattern just really quickly. Whoops, I did print it out bounce because this is 100 and this is size less than that. But okay. So 1 is true, 4, 3 is true. Like I said. Don't like it displayed this way, so let's try again. Okay, so let's see. 2 is false, 5 is false, 7 is false. Is there any pattern that I can discern? This isn't one of those, possibly. I don't know. I guess I'm going to YOLO a little bit and see if this is fast enough. Because this, let's see, what's 10 to the 5th, is it? I am skeptical, but you know, why not do a little bit YOLO? And if this works, then I will explain it a little bit better. It takes half a second, so it depends on how many points. Oh, I've done it before. Hopefully this is fast enough. It is fast enough. The 1.3 seconds a little bit slow down. Like, okay, So basically, the idea here, and I, to be honest, I really didn't think that this was going to be fast enough. That's why I didn't really explain it. 10 to the 7 to the 7.5 is what, like about like 33 million or something. Is that right? Um, so that's a little bit awkward, right? Something like that. I don't know. I don't know if that number is right, but still, like something like in tens of millions. It's a little bit slow for Python, but maybe these are very cheap operations, so that maybe is okay. But the idea is that, and this is really game theory thing, where basically you start at places where, you how do I explain this? This is like just so much math to really explain. Technically, some people get it by intuition, but like if you actually really want to be 100% correct, the math theory is like just like it's not an intro type thing that people could get. You have to do a lot of like just understanding it. But the idea, I'll get you started a little bit on the idea is that, let's say I'm at a certain space, right? And I say space as in like, I guess is it space? No, I mean I call it space almost like like a ladder almost, right? Like a ladder, you go up or actually in this case you go down and then try to go to zero. Zero is a forced move, but if you start at 1, you could get to 0. That means that you force the opponent to move on turn 0. And they cannot win. So that's basically what this one is saying. It's saying that 0 is a losing state, meaning that whoever starts there will lose, right? Starts their turn there will lose. So then that means that if it's your turn and you can make a move such that you get there, you win. If you cannot do that, that means that whatever move you do, the opponent will because if there's a move that you can make to make your opponent lose, then you take that move. Otherwise, any move that you take means that it is winnable for them, and that also means that by definition they have a move to make you lose. So that means that if the opposite is true, then you're forced, which is, or like that state is not winnable. So that's basically the idea, though of course it's very there are a lot of game theory type math that's actually behind that statement, but that's a concept kind of get into. Definitely play around with that and draw it out, visualize it as much as you can, either in one way or another. See what you can do. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later. Goodbye.